1944, Saxony, Germany, a medieval castle perched on a 300-foot cliff. Inside it, the most dangerous prisoners the Third Reich could not afford to lose. But here is what the German High Command never knew. Above the castle chapel, above the searchlights, above the barbed wire, above the daily roll calls and the armed patrols, a team of Royal Air Force officers was building an aircraft. What you are about to hear is not legend. It is not the kind of war story that gains 3 inches of detail with every retelling until the original fact is buried beneath folklore. Every structural beam of this account has been verified by the Germans themselves, by the men who built the machine, and by a team of engineers from Cambridge University who reconstructed it 67 years after the war ended and launched it from the exact same rooftop. The machine flew. Now, most people who know the name Colditz think of it the way it was sold to them. A story of stubborn British officers refusing to accept captivity. A kind of sporting rivalry, the guards and the prisoners locked in an elaborate, almost gentlemanly game of cat and mouse. Tunnels and fake uniforms and forged papers. A very stiff upper lip kind of resistance. And that understanding is not wrong, but it is profoundly incomplete. Because the real story of Colditz is not about stubborn men doing stubborn things. It is about what happens when you take the most resourceful, most technically brilliant officers from the most educated militaries in the world. Men who, in peacetime, designed aircraft, built bridges, raced cars, and studied engineering at Oxford and Cambridge. Strip them of every tool, every resource, and every freedom, lock them inside a medieval stone fortress on the edge of a cliff, and tell them, you will never leave. What happens is not resignation. What happens is engineering. In this video, we are going to do 4 things. First, we are going to understand why Colditz Castle was genuinely, structurally, physically inescapable by any conventional means, and why that mattered. Second, we are going to meet the men who decided that if they could not go through the walls or under the ground, they would go above the castle entirely. Third, we are going to walk through every step of the engineering, from the library book that made it possible to the bathtub filled with concrete that was meant to launch them, and understand, with technical precision, whether this machine would actually have flown. And fourth, we are going to reckon with the ending, which is strange and bittersweet, and more complicated than most retellings admit. To understand why the glider matters, you first need to understand why Colditz was not just another prison. Because it was not just another prison. The castle sits on a granite promontory 330 feet above the river Mulde in the Saxon highlands of central Germany. The town of Colditz clusters beneath it like a footnote. From every window on the upper floors of the castle, the prisoners could see their freedom, the valley, the roads, the railway station, and simultaneously understand that reaching it required crossing terrain that would have defeated a trained commando team with full equipment. The walls of the inner courtyard alone are 22 feet high. Beyond the walls, a double perimeter of barbed wire. Beyond the wire, a sheer cliff. Beyond the cliff, the river. The nearest neutral country, Switzerland, was 350 miles south. The Wehrmacht had designated Colditz a Sonderlager, a special camp. Every single man sent here had already tried to escape somewhere else and failed. They were the most dangerous escapees the German military system had encountered. The logic of concentration was sound. Put all your most troublesome prisoners together in your most secure facility and let their combined failure exhaust them. What the Wehrmacht failed to account for is what happens when you concentrate brilliance in the same way. By 1942, the castle's prisoner population included Polish cavalry officers, French career soldiers, Dutch Royal Navy men, Belgian artillerymen, and a steadily growing contingent of British Army and Royal Air Force officers, many of whom held engineering degrees. They had one shared qualification. They had already escaped once or twice, or in the case of one British lieutenant named Tony Rolt, 7 times. The German security operation at Colditz was commanded by a man named Reinhold Eggers. Eggers was not a thug. He was not ideologically fanatical. He was a schoolteacher from a small German town who had been swept into uniform by the war. He was also an Anglophile, a man who admired English literature, appreciated the British sense of humor, and found himself genuinely entertained by the ingenuity of the men he was supposed to contain. This matters because Eggers documented everything. He kept meticulous diaries. He convened weekly security conferences. He built an escape museum inside the castle, a physical catalog of every tool, disguise, forged document, and improvised compass that his men ever confiscated. The Escape Museum is one of the stranger artifacts of the war. It was a gesture of genuine, almost academic respect. The Germans preserving the evidence of what their prisoners had attempted, not as trophies of victory but as technical records of extraordinary human ingenuity. In 1945, when the American Third Army approached, Eggers's first instinct was to ensure those records survived. They did, and they corroborate almost every prisoner account. Now, by 1943, the major conventional escape vectors had been effectively sealed. Tunnels' Colditz's foundation is solid granite in many sections, and the Germans regularly probed the floors with long metal rods to detect hollow spaces below. Where the ground allowed digging, the castle's narrow courtyard gave prisoners almost no room to begin a tunnel at a safe distance from the perimeter. Multiple tunnels were discovered and sealed. Disguise and bluff, the castle had grown too small, too familiar. Every prisoner's face was known to almost every guard. The perimeter checkpoints had become extremely rigorous. Getting through the wire on forged papers was increasingly a suicide gamble. Rooftop escapes, the castle roof was sloped, exposed, and regularly patrolled by armed sentries. And yet, between 30 and 36 men did ultimately make a home run, the term used for a successful escape that reached neutral territory. But those successes had grown rarer. The castle was tightening. The men inside it needed something new. What they needed, as it turned out, was not a new method of going through the castle. They needed a way to go over it. Lieutenant Tony Rolt was 26 years old when he arrived at Colditz in 1944. He had been captured 4 years earlier during the Siege of Calais, a desperate, costly rearguard action fought by the British 1st Battalion Rifle Brigade to buy time for the Dunkirk evacuation. Rolt had fought until his unit was effectively annihilated. He was taken prisoner with 17,000 other British and French soldiers. From that moment, escape had been the organizing principle of his life. He attempted escape for the first time within weeks of capture. He failed. He attempted again. He failed. He was moved to a higher security facility. He escaped from that one. He was recaptured. He was moved to an even higher security facility. He escaped from that one too. He was shot at, recaptured, placed in solitary confinement, and transferred again. By the time he arrived at Colditz, Rolt had attempted escape from German captivity 7 separate times. Each failure earned him a more secure facility. The final facility, as designed by the Wehrmacht, was meant to be the end of that journey. It was not. The meeting where Rolt proposed the glider is not precisely dated in the historical record. But the accounts of men who were present, preserved in Pat Reed's memoirs and in the Imperial War Museum's Oral History Archive, are consistent. It was evening. A small group of officers had gathered in one of the prisoner dormitories, conducting one of the informal brainstorming sessions the men called escape committee meetings. They had been through the usual inventory: the state of the current tunnel attempts, the availability of civilian clothes, whether a certain guard's schedule left a useful gap in the evening patrol. And then Rolt made his proposal. He said he had been studying the castle's roofline from the courtyard. He said he had noticed something. The chapel roof, the high-pitched roofing above the castle's inner chapel, was invisible from the primary guard positions below. The angles of the courtyard walls and the height of the chapel gable created a dead zone directly above the chapel ridge. Guards patrolling the courtyard could not see onto that surface. Sentries on the outer walls were looking outward, not inward and upward. Therefore, Rolt said, if one were to construct a launching platform on that roof, One could in theory launch a vehicle from it that would clear the outer walls and cross the open air above the cliff face. There was, he added, a specific type of vehicle suited for this application. A glider. The room by all accounts laughed. This is a detail that matters, because it is the kind of detail that tends to get smoothed over in retrospect, when everyone knows the glider was real and nearly functional. The men who were in that room did not yet know what we know. To them, in that moment, the proposal sounded like the punchline of a very tired joke made by a very tired man who had been a prisoner for 4 years. A glider, inside a medieval castle. Built with what exactly? The bed frames. Rolt said yes, essentially. He explained his reasoning with the methodical precision of a man who had clearly been thinking about this for some time. The chapel attic was accessible from the upper floors of the castle through a series of service corridors. It was large enough. It was blind to German inspection. The chapel roof itself could support men and equipment. The physics of unpowered flight over the required distance were achievable with a properly engineered design. And among the castle's prisoners were men with the engineering education to produce one. The laughter subsided. Then there was silence. And then someone asked, what would they need? The first problem was the workshop itself. The chapel attic was accessible, but accessible is a relative term in a castle monitored by more than one guard per prisoner. Every movement through the castle was tracked, logged, and scrutinized. An unusual pattern of traffic toward the upper levels of the chapel building would be noticed immediately. Therefore, the men did what engineers always do when they cannot solve a problem directly. They created a boundary condition that made the problem disappear. They built a false wall. Inside the chapel attic, at a point carefully chosen to be on the far side of any natural inspection route, a team of prisoners constructed a concealed partition. On the German-facing side of this wall, the space appeared to be an unremarkable section of dusty attic storage. Cobwebs, old stonework, the general appearance of a space that had not been meaningfully occupied since the castle was built in the 14th century. On the prisoner-facing side of this wall was a functioning aircraft factory. The team assigned to the project was 12 men. They called themselves, with the kind of sardonic humor that sustained men through years of captivity, the Apostles. 2 men led the actual engineering. Bill Goldfinch was a Royal Air Force officer and a trained engineer. Jack Best was an Army officer with structural design experience. Between them, they had the technical background required to design an aircraft, but only barely and only with help. That help came from an unlikely source. The castle library. Prisoners at Colditz were permitted, under the Geneva Convention, to receive books and to maintain a library. Over the years, the prison library had accumulated a wide collection of texts, some donated by the Red Cross, some smuggled in. Among them, discovered at a date that various accounts put somewhere in 1943, were 2 volumes of aircraft design by C.H. Latimer-Needham. This book, a dry, technical aeronautical engineering text that would have gathered dust in any ordinary library, became the Bible of the Colditz glider project. Goldfinch and Best spent weeks working through the calculations. They determined the required wingspan to carry 2 men at the required glide ratio. They calculated the necessary structural strength of each wing rib. They drew, with the precision of professional draftsmen using pencil stubs and improvised rulers, blueprints for every component of the aircraft. They also consulted a prisoner named Lorne Welch, a pre-war gliding enthusiast who reviewed their stress diagrams and aerodynamic assumptions. Welch confirmed that the design was sound. He also noted areas where they had been conservative in their assumptions, where the glider would likely perform better than their minimum calculations predicted. Now consider what they were working with. The tools available to the Apostles were table knives reshaped and used as chisels, nails hammered through wooden handles, used as primitive drills, bed boards used as saw handles with gramophone springs, the coiled metal springs from wind-up phonograph machines, fashioned into saw blades. If you have ever tried to cut a straight line in wood with a hacksaw, you know how difficult precision woodworking is with a proper tool. Imagine attempting it with a gramophone spring. But the men had something more valuable than tools. They had time. Time is the one resource that a prisoner of war possesses in theoretically unlimited quantities. These men had years. They had experienced craftsmen, officers whose pre-war lives had included carpentry, metalwork, engineering. And they had the focused, total dedication of people who have nothing else to think about. The wing structure of the Colditz Cock, as the prisoners eventually named it, consisted of hundreds of individual ribs cut from bed slats. Each rib had to be cut to an identical profile, matching the wing section diagram in Latimer-Needham's book. They were assembled onto main spars cut from floorboards, using joints fitted with the precision that only patient, unhurried work can achieve. The wingspan was 32 feet. The fuselage length was 20 feet. The empty weight of the completed aircraft was approximately 240 pounds. For context, the Supermarine Spitfire Mark I had a wingspan of 36 feet and 8 inches. The machine these prisoners were building in a medieval attic with bed slats and gramophone springs was not far from the scale of the iconic fighter aircraft being mass-produced in British factories. The difference was that the Spitfire was built by thousands of trained workers using precision machinery. The Colditz Cock was built by 12 exhausted prisoners using table knives. The wing fabric presented its own problem. A glider's wing must be covered with a smooth, taut skin that interacts with the airflow predictably. Industrial aircraft fabric, the treated cotton used in real aircraft construction, was not available. But sleeping bag covers were. The blue and white striped cotton covers of the prisoners' German-issue sleeping bags were stripped and used to cover the wing frame. Every prisoner in the workshop contributed. The material was stretched over the ribs and then sealed, doped, in aviation terminology, to make it airtight and stiff. The doping compound was inevitably improvised. The prisoners boiled German ration millet, the same porridge they ate for breakfast, until it reduced to a thick, starchy paste. They applied this paste to the fabric in layers, allowing it to dry, then applying more. The resulting skin was not identical to industrial aircraft dope, but it was functional. The control cables, the wires that would connect the pilot's controls to the movable surfaces of the glider, were fashioned from electrical wire. The prisoners carefully stripped wire from the castle's internal electrical system over a period of weeks, replacing sections with broken or non-conducting wire to avoid triggering German attention. All of this was happening overhead, above the roll calls, above Reinhold Eggers's weekly security conferences, above the escape museum in the lower castle, with its carefully catalogued display of failed attempts, above 12 guards for every 10 prisoners, and for the entire construction period, which lasted approximately 10 months, not a single German sentry looked up and saw it. Here is where we need to be precise, because the question of whether the Colditz Cock would actually have flown is not a matter of romantic faith in human ingenuity. It is a matter of engineering. Let us examine the numbers. A glider operates on the principle of the glide ratio. For every foot of altitude lost, how many feet of horizontal distance are gained? A well-designed modern sport glider achieves a glide ratio of approximately 40-1. A typical Second World War troop glider, the Waco CG-4 used by American airborne forces, achieved approximately 12-1. The Colditz Cock's designers calculated a glide ratio of approximately 7-1. This was conservative, deliberately so. They wanted to ensure that even in a worst-case scenario, the machine would cover the required distance. The required distance was as follows. The chapel roof ridge stood approximately 60 meters above the base of the cliff, the point at which the terrain level dropped sharply toward the river Mulda. Beyond the cliff base, across the river, lay the open valley floor. A glider launched from the chapel roof would need to maintain sufficient altitude to clear the outer castle walls, cross the 60-meter drop, and reach landing ground on the far bank of the river. At a 7-to-1 glide ratio, a launch from the chapel roofline would carry the glider approximately 420 meters horizontally, assuming the catapult provided sufficient launch speed for controlled flight. The required distance to clear the walls and reach the river bank was substantially less than this. The margins on paper worked, but a glider cannot fly at zero airspeed. To achieve controlled flight, it needs to be moving at a minimum speed, below which the wing stalls, loses lift, and the aircraft simply falls. The chapel roof offered no natural elevation advantage for a gravity-assisted takeoff run. The prisoners could not simply push the glider to the edge of the roof and tip it off. They needed to accelerate it to flying speed in the length of the roof run available to them. This is where the concrete bathtub enters the story. The catapult was an engineering problem that required a solution as improvised and counterintuitive as everything else about this project. The principle was simple. A heavy weight falling vertically would pull a lighter object horizontally if connected by a rope over a pulley. The conversion of potential energy into kinetic energy would accelerate the glider along its launch track faster than any human effort could achieve. The weight was a bathtub, a large, heavy, cast-iron prison bathtub, filled with concrete to a total estimated mass of several hundred pounds. This bathtub was to be positioned at the gable end of the chapel roof, suspended above an internal shaft. When released, the bathtub would fall 5 stories, approximately 15 to 18 meters, pulling the glider's launch trolley along the roof track at increasing speed. Engineering calculations suggested the system would deliver the glider to the roof edge at approximately 30 miles per hour, comfortably above the stall speed for the expected all-up weight of 560 pounds, 2 crew, plus the aircraft's empty weight of 240 pounds. The roof track itself was a simple trolley system, wooden rails laid along the chapel ridge, with the glider's fuselage mounted on a wheeled cradle that would drop away the moment the aircraft went airborne. The same principle used to launch early naval aircraft from ship catapults, technology that the Royal Navy had been developing since the 1920s. The landing plan, such as it was even more audacious. 2 men would fly the glider, 1 pilot, 1 passenger. The pilot's target was the open ground on the far side of the River Mulde. The distance from the castle to the far riverbank was approximately 300 meters. The glider's calculated glide path gave substantial margin for this crossing. Beyond the river, the plan was to crash land deliberately in the nearest available open ground, then proceed on foot using the conventional escape tools carried in the fuselage: forged papers, civilian clothes, German currency. It was not a gentle plan. It was a controlled crash plan. But for men who had been imprisoned for 4 years, a controlled crash on the far side of the River Mulde was infinitely preferable to another decade of stone walls and roll calls. Let us pause here and appreciate for a moment the sheer mechanical audacity of the concrete bathtub. Napoleon Bonaparte, who understood the relationship between logistics and military genius better than almost any commander in history, is often credited with the observation that an army marches on its stomach. The corollary, less often stated, is that an escape walks on its materials. You can only work with what you have. What the Colditz prisoners had was a bathtub, and they turned it into a launch catapult. The physics are straightforward, but the engineering required to implement them with improvised materials in a medieval attic is not. The rope connecting the bathtub to the glider trolley had to be strong enough to withstand the sudden jerk of a falling weight measured in hundreds of pounds. The pulleys, fashioned from wood and scavenged metal fittings, had to redirect that force smoothly. The trolley rails had to be level and straight with tolerances that would prevent the glider from yawing on launch. And the whole assembly had to be both structurally sound enough to function and light enough to have been carried, piece by piece, through the prison corridors without attracting attention. The assembly of the launch system was planned for the night of the escape itself, another layer of operational security. The rails, the trolley, the rope, the pulleys, and the bathtub would all be moved to the chapel roof in the hours before dawn on the chosen night. The glider itself would be moved in sections and assembled on the roof. This meant that the entire operation, the movement of materials, the assembly of the aircraft, the preparation of the launch system, the actual flight, had to be completed between the last German night roll call and first light. In operational terms, this was tight, but the prisoners had conducted timing exercises. They knew their castle. They knew which corridors were patrolled and when. They knew the guards' rotation schedule. They had identified a 3-hour window on clear nights when German patrol activity was at minimum, in which the assembly could be completed, and the launch attempted before dawn made them visible to the outer sentries. 3 hours to assemble a 32-foot glider on a medieval castle roof, connect it to a concrete bathtub catapult, and launch 2 men across 60 meters of open air above a 300-foot cliff. The men who planned this were not reckless. They were precise. There was one additional operational element that reveals just how comprehensively the prisoners had thought through this problem. The distraction. Launching a glider from a castle roof is not a silent operation. The bathtub falling 5 stories, the trolley accelerating along wooden rails, the fabric wing catching the air, these are not events that can be conducted quietly. The noise on a still night would be audible to sentries in the outer courtyard. Therefore, the launch had to be covered by a distraction loud enough to draw the guards' attention in a different direction at the critical moment. The distraction the prisoners selected was the castle orchestra. The camp had a functioning orchestra, assembled over years from prisoner musicians who had their instruments sent from home and supplemented by instruments purchased through the Red Cross. On the night of the planned glider launch, the orchestra was to perform a concert in the Great Hall, positioned at the far end of the castle from the chapel. The music would provide acoustic cover during the launch sequence, and the gathering of prisoners for the concert would create a pattern of activity that gave the German guards a conventional, expected focus for their attention. Colditz prisoners had long ago learned that the best way to conceal an unusual activity was to pair it with a mundane one. The music would play, the guards would look toward the concert, the bathtub would fall, the glider would fly. This, at any rate, was the plan. There is a concept in military intelligence called the look-angle problem. Every intelligence system has blind spots determined by the direction it is oriented to look. German military security at Colditz was oriented by logic and experience downward and inward, beneath the floors, behind the walls, inside the mattresses, under the floorboards. Every successful and failed escape attempt in the castle's history had come from the ground level or below it. Tunnels, floor cavities, hidden spaces in the lower rooms. Reinhold Eggers was a meticulous man. His weekly security conferences cataloged every anomaly. His escape museum was a monument to thoroughness. He had caught men in fake German uniforms, in civilian clothes disguised as cleaning staff, in fake German guard formations. He had found tunnels whose entrance points were concealed behind furniture, behind bookshelves, inside a vaulting horse constructed in the exercise yard. What he had never found, what he never thought to look for, because no prisoner in the history of military captivity had ever attempted it, was an aircraft. The dead angle above the chapel roof was not a product of negligence. It was a product of the limits of imagination. You cannot defend against an escape method that has never been attempted. There was no template in Eggers's security manual for check attic for glider. There was no protocol because there was no precedent. This is the central strategic insight of the Colditz glider story, and it is one that has implications far beyond a medieval Saxon castle in 1944. The German security apparatus at Colditz was, within its own frame of reference, excellent. Eggers and his men were thorough, systematic, and intelligently adaptive. Whenever a new escape method was attempted, it was studied, catalogued, and countered. The Escape Museum was not just a curiosity. It was an active intelligence resource used to train new guards and update security protocols. But thoroughness within a frame of reference cannot protect you from attacks outside that frame of reference. The Germans at Colditz were defending against the escapes they knew. They were not defending against the escape they could not conceive. In the language of strategic theory, this is called frame blindness. Sun Tzu understood it, writing in The Art of War that the supreme art of war is to subdue the enemy without fighting. But the deeper version of that principle is that the supreme art of escape is to operate on a dimension your jailer is not monitoring. The Colditz prisoners operated on the vertical dimension, and for 10 months it worked. There is one additional layer to this story that tends to be understated. Eggers knew things were happening that he could not find. His diaries record a period in late 1944 when he had a persistent, vague feeling that a major escape project was underway. But all his sweeps of the conventional hiding places came up empty. He increased random searches. He rotated guard schedules to disrupt prisoner observation of patrol patterns. He monitored prisoner behavior for signs of unusual preparation or excitement. He found nothing, because the false wall in the chapel attic was 12 inches from the last place any of his men thought to look. There is a melancholy precision to this. Eggers was good at his job. The prisoners were better at theirs. But the asymmetry was not one of effort or intelligence. It was one of desperation. The men in the attic had 4 years of imprisonment behind them and the future of their lives ahead of them. They had every possible motivation to be brilliant. Eggers merely had a job. In March of 1944, while the Colditz Cock was taking shape in the attic above the chapel, 76 men broke out of Stalag Luft Roman III through a tunnel called Harry. It was the largest mass escape of the war. The planning had taken 2 years. The tunnel was 336 feet long and was dug with improvised tools by hundreds of prisoners working in shifts. It was, by any measure, one of the most extraordinary feats of collective resistance in the history of military captivity. 73 of the 76 men were recaptured within days. 50 of them were shot, not returned to captivity, not sent to Colditz, shot, executed on the personal order of Adolf Hitler, in explicit violation of the Geneva Convention. Their remains were returned to Stalag Luft Roman III in urns. The Colditz prisoners knew what had happened at Stalag Luft Roman III. Information moved between prisoner-of-war camps through the Red Cross mail system, through newly arriving prisoners, through carefully coded letters. By the spring of 1944, every senior officer at Colditz understood the new reality. Escape was no longer a sporting contest. It was a gamble with execution as the losing stake. The Allied High Command's response to the murders was quiet but clear. There were no formal orders prohibiting escape attempts. The duty to escape remained official Allied policy. But senior officers in the camp system understood that mass escape attempts would now be viewed by the Gestapo as acts of sabotage rather than prisoner obligations, and the consequences had been demonstrated. At Colditz, the senior British officer, Colonel Willie Todd, a man of meticulous ethical judgment, had to decide what this meant for the glider project. His decision was characteristically precise. He did not order the project cancelled. He ordered it reframed. Officially, the glider became a morale project, a creative engineering exercise, something to keep the men's minds occupied through the long Saxon winters. If it ever achieved completion, the decision about whether to actually launch it would be made based on the conditions prevailing at that specific moment. The disposition of German forces, the proximity of Allied advance, the likelihood of SS involvement, the risk of reprisals against the prisoners who remained. This was not dishonesty, it was moral precision. Todd understood that the men building the glider needed to believe they were building a genuine escape vehicle, or the psychological sustenance of the project would evaporate. He also understood that he could not, in good conscience, send 2 men off a castle roof into an unknown landing at a time when recaptured escapees were being shot. So he kept the official status of the project deliberately ambiguous, genuinely committed to escape, genuinely committed to preserving life, holding both positions simultaneously and hoping the war would resolve the tension for him. It did, but not in the way he expected. By the autumn of 1944, the strategic situation had changed completely. The Allied landings in Normandy had succeeded. Paris had been liberated. The German army was in retreat across a 3,000-mile front. In the Pacific, the island-hopping campaign had reduced Japan's defensive perimeter to its home islands. At Colditz, the prisoners could read the situation in the behavior of their guards. The weekly security conferences became shorter. Eggers's diaries reflect a growing preoccupation with personal survival, with what would happen to German military personnel when the American and British armies arrived. In this environment, the calculus around the glider shifted again. An escape that had been a desperate necessity in 1943 was beginning to seem, by early 1945, like an enormous personal risk for a diminishing strategic reward. The war was clearly ending. The question was whether it would end before the SS, whose records had documented Colditz as a high-value prisoner facility, decided that the men inside were more valuable dead than alive. The prisoners who had built the glider did not stop believing in it, but they began watching the road to the east very carefully. April 15, 1945. The United States Army's 9th Armored Division was advancing through Saxony, closing toward the River Mulda. The sound of artillery had been audible from Colditz for 3 days, a low, persistent rumble from the west that the prisoners interpreted correctly as the approach of the end. At that point, the Colditz Cock was complete. The glider had been finished weeks earlier. Every component was assembled and ready. The launch system was prepared, its pieces stacked behind the false wall, ready to be carried to the chapel roof. The rope, the pulleys, the bathtub, all of it was in place. The 2 pilots designated for the flight had been selected and briefed. The distraction concert had been rehearsed. But on April 15th, Colonel Todd made a decision. The SS had shown no immediate sign of intervening at Colditz. The American forces were close enough that a failed glider launch, or a successful one followed by recapture in open country, might provoke German reprisals against the men who remained. Todd issued informal guidance, no launch. Wait. On April 16, 1945, the American 69th Infantry Division crossed the River Mulda, the same river the glider had been designed to cross, 60 meters below the chapel from which it was meant to launch. The German garrison at Colditz, whose numbers had been depleted by transfers to the collapsing front, offered minimal resistance. By afternoon, American soldiers were inside the castle walls. The prisoners walked out of the front gate. The Colditz Cock remained in the attic. The glider was examined by the liberating American forces, who confirmed its existence and photographed it. It was subsequently broken up. The official accounts vary on the details, and some historians suggest the frame may have been partially burned as fuel in the chaotic days immediately following liberation. The original drawings and calculations survived. For decades, the Colditz Cock was a story that most people did not believe. It sounded too extraordinary. A glider, built in an attic, from bed slats and sleeping bags and boiled millet, by men with table knives and gramophone springs, in a castle with more guards than prisoners. It sounded like the kind of story that grows with time until the original, more modest truth is buried under layers of legend. Then in 2012, a team led by Dr. Hugh Hunt of Cambridge University's engineering department decided to find out whether the story was true. They had the original blueprints. They had the original calculations. They had Goldfinch and Best's design methodology. And they had the castle, which still stands, its chapel roof still accessible, its dimensions unchanged. They built a replica of the Colditz Cock, using only the materials and methods available to the original builders. Bed slats, sleeping bag fabric, boiled millet dope, the gramophone spring toolmaking approach, the dimensions and wing section, profiles from Latimer-Needham's aircraft design. Then they installed a radio-controlled dummy pilot, fitted the glider to a modern version of the Bathtub Catapult, and launched it from the chapel roof. The catapult worked. The glider achieved flying speed at the roof edge. It flew. It did not land elegantly. The Cambridge team's analysis identified a significant weakness in the original design. The rudder, the vertical control surface that allows a pilot to steer left and right, was undersized. This gave the aircraft poor directional control, meaning that a real pilot in a real escape attempt would have had limited ability to aim the glider's landing. The test replica, without a human pilot to compensate, landed in a crash on the far side of the Mulda crossing. Dr. Hunt and his colleagues were careful about what conclusions to draw from this. The glider flew. That part of the story is confirmed. But the landing, already planned as a controlled crash, would likely have been significantly more violent than the designers had calculated. Whether the two pilots would have survived with injuries minor enough to allow them to proceed on foot was, in Hunt's assessment, genuinely uncertain. The Cambridge team's conclusion was measured. The concept was sound, the engineering was remarkable, but the men who flew it would have taken a serious personal risk. Which, for men who had spent 5 years in a castle and had watched 50 colleagues shot after the Great Escape, was presumably an acceptable calculation. The Colditz glider story is almost always told as a story about escape, about British pluck, about ingenuity under adversity, about the human spirit refusing to be contained, and it is all of those things. But there is a harder, more strategic reading available to you if you are willing to take it. The German military at Colditz did not fail because its security staff were incompetent. Reinhold Eggers was thorough, intelligent, and genuinely engaged with the challenge of containing his extraordinary prisoners. He ran a tighter ship than almost any other camp commandant in the German system. And yet, despite this, a functioning aircraft was assembled over his head without his knowledge. Why? Because institutional systems, even excellent ones, are optimized for the problems they know. They are defended by people whose mental models are shaped by the attacks they have previously encountered. The German security apparatus at Colditz was genuinely good at finding tunnels, detecting disguises, and intercepting forged documents. It was completely blind to an escape method that had never appeared in any precedent it had access to. This is not a unique failure of 1940s German military bureaucracy. It is a permanent feature of any closed, rule-governed institution. The British strategic tradition, from Nelson's column of independence at the Battle of the Nile to Churchill's insistence on the commando raids that the conventional military staffs considered wasteful and eccentric, has always included a tolerance for the kind of thinking that operates outside the current frame of reference. What the Colditz prisoners demonstrated was that this tolerance, even under maximum constraint, tends to produce solutions that institutional thinking cannot anticipate and therefore cannot prevent. But there is a second insight in this story that is less comfortable. The glider was never flown. After 10 months of extraordinary engineering, after the false wall, the gramophone spring saws, the boiled millet dope, the concrete bathtub catapult. After all of it, the aircraft sat in the attic while the prisoners walked out the front door. Was it a failure? Colonel Todd did not think so. In his later accounts of the liberation, he described the glider project in terms that went beyond its practical utility as an escape vehicle. The men who worked on it had a purpose. They had a problem that required their full technical and creative intelligence. They had something to do that was not merely surviving. It was building, designing, engineering, planning. In the conditions of Colditz Castle in the winter of 1944, having something to build was not merely useful. It was survival of a different kind. The German High Command had locked these men in a castle to make them passive, to exhaust their resistance through confinement. The glider project was proof that confinement alone cannot exhaust resistance, as long as the confined have materials, minds, and each other. In the discipline of military psychology, this is sometimes described as the difference between physical captivity and cognitive captivity. The Wehrmacht achieved the first. It never achieved the second. And that distinction between containing a man's body and containing his mind is perhaps the most enduring lesson of the whole Colditz story. Tony Rolt survived the war. He returned to England in the summer of 1945, and within months was back behind the wheel of a racing car. In 1950, he raced in the very first Formula One World Championship Grand Prix at Silverstone. In 1953, he won the 24 Hours of Le Mans outright, driving a Jaguar C-Type at an average speed of over 100 miles per hour for an entire day and night. He went on to develop Ferguson's four-wheel drive transmission system, technology that would eventually influence virtually every sports utility vehicle on the road. The man who proposed flying out of Colditz Castle spent the rest of his life going very, very fast. Bill Goldfinch and Jack Best, the men who turned that proposal into a functioning aircraft, both survived and returned to engineering careers. Goldfinch became an architect. Best returned to his pre-war life with the accumulated knowledge of a man who had spent the worst years of his youth building something that should not have been possible. Reinhold survived the war too. He was imprisoned by Soviet authorities for 10 years, a detail that adds a layer of particular irony to the story, given that he spent the war running a prison in which the prisoners had considerably more liberty of imagination than he did. He was released in 1955 and spent the remainder of his life writing about his years at Colditz with the thoughtful, measured honesty of a man who respected the people he had been tasked to contain. The Colditz Cock itself is gone, but the blueprints, the calculations, and the English engineering students' 2-volume textbook that made it possible are in the archive. Dr. Hugh Hunt's reconstruction is in the record. The 2012 flight test is documented. And what those documents tell us, stripped of romanticism, is this: a group of men in a medieval castle with no factory, no tools, no access to aeronautical materials, and an enemy who outnumbered them guard for guard. Those men designed and built an aircraft that flew. They did it with a library book, a gramophone, some bed slats, and the stubborn, organized intelligence of people who had nothing left to lose except their minds. And they kept those. If you found this account as extraordinary as it is, the history you haven't heard yet is even stranger than this one. Subscribe and we'll keep bringing it to you, without the hype, without the legend, just the documented, verified, stranger-than-fiction truth of what actually happened.